Okay, the last thing that's important for the residual plot, okay? It helps us understand if the model is appropriate to use for prediction. Let me rewind and tell you a story. If I was with you in class, I would ask you a question. I would say, if I wanted to measure my husband's height, I could have him stand against the wall and mark it. Would it be appropriate for me to measure his height with a ruler? No. There's a better model out there. I could do it, but it's going to take me some time, and there's probably going to be some errors using a ruler. Okay, human error, that is, right? Because I have this ruler and then I'm going to mark and mark again. That's not appropriate. There's something better out there. There's a better tool out there, and that would be a tape measure. Okay, that would be a tape measure. So when looking at the residual plot, this is going to help us understand if that model is appropriate to use for prediction. How do we tell by looking at that residual plot? Well, we tell and we want to see if we can look and see if there's a pattern. If there's a pattern in our residual plot, the model used for prediction is not appropriate, and there's a better model out there. Take a second and write these things down. Okay, now you're probably wondering, well, what does this look like if it's a bad residual plot? What does it look like if it's a good residual plot? How am I going to know? Let me show you some examples right now. Here's our first residual plot, okay? So there was a data set. And what happens then is we calculated the residual plot, and we got this residual plot. Now, this residual plot is a bad residual plot. Why? In statistics, we call this a pattern. This is actually called a fan. Think of it back when you were a little kid and you would make them, maybe you still do, I don't know. My daughter loves to make these though. You make these fans, right? It's got this real thin part and then it fans out. That's not okay in statistics. So what we say, if we get a residual plot that looks like this, we say the least squares regression line for this data set is not appropriate to use for prediction. Why? Because there is a pattern in the residual plot. Again, for this data set, the least squares regression line is not appropriate to use for prediction. Why? Because there's a pattern in the residual plot. Let's look at another pattern in statistics. Here's a residual plot. Hopefully you're noticing there's a U here. Okay, that's considered a pattern in statistics. What would we say? If you were asked, is this least, for this data set here, is the least squares regression line appropriate for prediction? You would say no. Why? Because there's a pattern in the residual plot. Finally, here's one more bad one. An upside down U, okay? An upside down U. Again, this is considered a pattern in statistics. The data set for this residual plot, the model, okay, the least squares regression line that was generated is not appropriate for prediction. Again, why? There is a pattern in the residual plot. Well, what does it look like to not have a pattern? You just don't want to see a shape. You don't want to see U's, and you don't want to see fans. Let's look at a good one. So we had a data set, a regression line was built, and then we looked at the residual plot. This is a great residual plot. If you look, if you look at like the positive residuals, there's nice, pretty much equal variance up and down throughout. If I would draw a line up here, and I would kind of color it in, it's pretty equal throughout, okay? Pretty equal throughout. And the same goes for those negative residuals down here. A nice kind of color in where the residuals are up and down. It's pretty equal, okay? You don't see any clear-cut shape. So if you had a data set and you generated a least squares regression line, and then you looked at the residual plot and you got a residual plot that looked like this, and then you were asked, is the least squares regression line appropriate for prediction? You would say yes. Why? because there is no pattern in the residual plot. Here's another one that looks really nice. Okay. Again, the positive residuals, the negative residuals, nice even variation throughout. No pattern like what we see over here. Okay. Is the regression line for this data set appropriate for prediction? Yes. Why? Because there's no pattern in the residual plot. Okay. Last thing we want to do is we want to just generate a residual plot on our calculator so you know how to do it. Okay, so we're going to go up to L1. You can type in what I have for L1. Okay, so 20, 21, 22, 23, 24. Do that now. And then I'm going to just make up some data here. Let's put in 20, 25. Let's do 23. Let's do 24. And then finally, let's do 27. Okay, just some made up data. In order to generate a residual plot, the first thing you have to do is you need to run regression. Okay, let's actually look at this data plot though, or this scatter plot first. So I'm hitting second y equals. I'm hitting enter on plot 1. Okay, I'm all set to go. I'm on. I have the scatter plot right there, and then I'm going to hit zoom 9. Okay, so you can see a somewhat linear scatter plot right there. Okay. Next, let's look at the residual plot, okay? If we would generate a line, would the residual plot tell us if our line is appropriate for regression or not? Well, in order to do that, I actually need to run regression. So I'm going to go to stat, I'm going to arrow over to calc, and I'm going to go down to number 8. I can actually store that regression equation in there. Okay, so watch what I'm going to do. I am going to go to vars. I'm going to go over to y-vars. Oops. And if you have an old calculator, I can show you how to do this during office hours. Y1, it's not necessary. You don't have to store it. And I'm going to calculate. So we have our regression equation there. And if I go back to zoom 9, what happened is now we have that line going through it. Okay, now let's look at the residual plot. Okay, to look at the residual plot, again, we put it in L1, L2. We then look at the scatter plot, make sure it's straight enough because there's no sense in doing it if we know we have a curved relationship, right? Then we know a linear model is not okay. So we look and we make sure it's straight enough. We run regression, and now we're going to look at that residual plot. So let's do that now. Go to plot 1, hit enter. And now we still keep it on scatter plot. And on our x-axis, we're saying we want L1. That's our explanatory variable. But on our y-axis, now what we want is we want the residuals for the regression that we just ran. So in order to get those residuals, what we do is we hit second, stat, and if you scroll down, you should see residual. Number 8 for me, it might be number 7 for you. Now I'm going to hit zoom 9, and you can see here, this residual plot's not great, but I don't have a lot of data, but I also don't see a shape. I don't see a fan. And I don't see a U. So I'm comfortable here saying, hey, our residual plot, okay, our residual plot showed us that our regression line that we just ran is okay for prediction. Why? Because there's no pattern in our residual plot. Okay, guys, that's all we need about residual plots. I hope you guys have a fabulous day and take care. Stay safe.